Breaking strength of a certain make of fishing line has a normal distribution, standard deviation 1.02. Random sample of 9 lives is tested, 9 lines. Mean breaking strength of the sample and of the population are x bar and mu. The null hypothesis is mu is 3.69. One-tail test, so alternative mu is less than 3.69, 5% level. Show the range of values for x bar for which the null hypothesis is rejected is given by x bar less than 3.13. This is one of those hypothesis tests where you are to find the critical value. That's basically what they're asking for here. It's a 4-mark question, question 11. So, just at the top, I've stated basically what we've been given in the question. It's a normal distribution. Mu we don't know, but we know the variance, we know the sample size, we know our hypothesis, we know it's a one-tail test, we know we're using 5%. So, we've got to use, because the null hypothesis says mu is 3.69, that's the mu that we've got to use for our calculations. So up here, I can change that mu to be 3.69. And I think it does say as well, somewhere that's for the population. So there's my distribution. Because I'm dealing with a sample, I need the distribution of x bar. So I need sigma squared over n for my variance. And I need to find a critical value such that the probability of being lower than that is 0.025%. I'm looking at this now and I'm thinking that may not be correct because it's a one-tail test and that should be 0.05%. We'll see if I've corrected that as I go through then. I have on the next line. Okay, so there we go. It's x minus mu over standard deviation. Phi of that is 0.05 because it's a one-tail test. Anti-phi both sides. Anti-phi this side and substitute the values in. Anti-phi 0.05, you get minus 1.645. Then it's just a case of rearranging that to get C, which comes out to be 3.13. So it's 4 marks altogether. They gave 1 mark for the correct sigma squared over n. They gave 1 mark for having the correct z value of minus 1.645 and 2 marks for getting the value, 4 marks altogether for that question. That was quite quick.